So in problem 1 here, we have a clinical trial that's conducted for a new malaria vaccine. After vaccine administration, 14% of the patients taking the vaccine contracted malaria, as opposed to 20% here that were in the placebo group. So 14% for the vaccine, 20% for the placebo group. We want to know what number of subjects, so this is a sample size question, would be required to detect a difference in proportions. So those are keywords there. Difference in proportions. Proportions are dichotomous outcome, and we're doing a difference, so this is 2 sample, and you would suspect 2 sample here because we've got 2 percentages here, a vaccine group and a placebo group. We're using 80% power, alpha is 0.01, and we have a 2-sided test. So if we go to table 8.1, which is our sample size formulas here, we are looking for dichotomous 2 sample. So dichotomous 2 independent samples here. This first column is for confidence intervals, and the second column is for hypothesis test. We're looking at a hypothesis test. So that is this formula here. That is a square in the exponent. And then ES, remember, is effect size. So I went ahead and brought that formula in here and down here. And we need Z1 minus alpha over 2 and Z1 minus beta and the effect size. So our alpha is 0.01, and then our beta is 20%. The power is 1 minus beta, remember. So 1 minus beta is 0.80. So Z1 minus beta is Z0.80. And remember that 0.80, that is the left area. So we want the Z value that has 80% to the left. So I'm going to do this in the distribution calculator, Excel distribution calculator. We're given the area, and we want the z-score, so we want to use the inverse norm tab here. We're dealing with z-scores, so we're going to keep our mean at 0 and our standard deviation at 1. Left area is 0.80, and just press enter. And our value is 0.842, and that 0.84, you should have seen that before in some other problems in the textbook. So we'll keep 2 decimal places to be consistent with the text. So this is 0.84, and then alpha is 0.01, so this alpha over 2 is 0.005, 1 minus 0.005, that's this 0.995. So that's the z-value with 0.995 to the left. So we'll go back to our Excel distribution calculator and put 0.995 in that box to get 2.576. So we've got those. Now we need to compute our effect size. That formula is here, P1 minus P2 in absolute value, so whichever difference is positive, over square root of P1 minus P, and your P is the average of the 2 proportions for the null and alternative hypothesis. So if we take P1 to be 0.20 and P2 to be 0.14, then P is going to be the average of those, 0.20 plus 0.14 divided by 2. So that is 0.34 divided by 2, which is 0.17. And so then our effect size in the numerator, we're going to have absolute value of 0.20 minus 0.14. And then we're going to divide by square root, 0.17, 1 minus 0.17. So if you enter that into the calculator, you will get 0.15973 to 5 decimal places. And now we can go ahead and make our substitutions. N sub I is the number in each group. So this is going to be 2 times in the numerator. We got that Z1 minus alpha over 2. That's the 2.576. And the Z1 minus beta, that's our 0.84. And we're going to divide by the effect size, which is 0.15973. And that whole thing gets squared. And if you enter this into the calculator, you'll get 914.73. And we always round up with sample sizes. So this would go up to 915, and that's going to be per group. So 915 in the treatment group and 915 in the control group or placebo group. Now, just a general note here as you're doing sample size problems, if you have a crossover trial, then we treat a 2-sample test like it's a 1 sample because each individual acts as their own control. Also, if you see the terms risk difference or difference in proportions, those indicate a 2-sample situation. So difference in proportions here, those were keywords indicating a 2-sample.